Hello students. So today we are going to discuss about chemical reactions and equations. Now, before we start with the chapter, we first need to understand what exactly do you mean by the term chemical reaction. Okay. Now, what is a chemical reaction? A chemical reaction is a process in which atoms or group of atoms rearrange themselves to form a new product. Okay, once again let me repeat, what is a chemical reaction? A chemical reaction is a process in which atoms or group of atoms rearrange to form a new product. Okay, please understand, you will term a process as a chemical reaction only when you get a formation of a new product. Otherwise it won't be referred as a chemical process. Now let's understand, when we talk about process, as I said, we could have two types of processes. The first could be a physical process and the second could be a chemical process. Okay, so what exactly do you mean by a physical process? A physical process is a process in which no new product is formed. Okay, understand, over here you are not getting anything new, you are not having a new product which is formed during a change. Okay, like for example, if we take few examples like freezing of water, you could freeze water, you could again unfreeze it. Okay, or similarly we can say mixing of sand and water, or dissolving of sugar in water, crushing of can is all example of a physical change. You could have another examples like melting of wax. Okay, shredding of paper, tearing of paper is nothing but a physical change, because when you tear a paper you're essentially just changing the size and not the properties of that substance. Okay, even if you tear a paper you are still able to write on it, it will see it will retain the exact same properties. Okay, so you're not forming any new product, and therefore we will say that this will be a physical change. However, on the other hand, a chemical process is a process in which a new product is formed. This is very important. You get a new product. Okay, that means if I take an example from day-to-day life, okay, we can have examples like ripening of mangoes, okay, or fermentation of grapes, or rusting of iron. Few other examples like combustion, digestion, okay, rusting of iron, baking, all of them are nothing but examples of a chemical change. Okay, like for example, if you combust, if you burn anything, you won't be able to retrace it into the same form. Okay, let's say if you burn a paper, you won't be able to make paper once again. Okay, now over here understand that chemical properties or chemical processes, sorry, they might be reversible or they might be non-reversible. Okay, there are few processes which can be reversed, there are majority of the processes which cannot be reversed. Like for example, if I say formation of ammonia is a reversible process, don't worry about it, we'll learn it shortly in this chapter. Okay, but then yes, there are chemical processes which are reversible, there are chemical processes which are irreversible, and majority of the reactions that we know as a chemical reaction are irreversible reactions. Okay, all the examples like ripening of mango, photosynthesis, or you can say fermentation of grapes, digestion, rusting, baking, okay, all of them are nothing but examples of chemical changes which we know are irreversible. Okay, let's move further. Now whenever we say that okay, a chemical reaction is happening, how would we come to know that a chemical reaction is happening? We need to have some observable changes, right? We need to observe few changes in the chemical reaction so as to say that yes, a chemical reaction has occurred. So what all are the observable changes that we can observe? Then there are many, out of which few are, you can observe a change in color. Like for example, when we say during baking or during ripening of mango, okay, initially the mango was green, later on it turned into orangish yellow, so definitely there is a change in color. Okay, then there might be change in state. Okay, there are certain reactions in which there is change of state. For example, let's take for example combustion. Okay, the wood that we burn would get converted into carbon dioxide. Wood is solid, carbon dioxide is gaseous. Okay, so you can have change in state, okay, or you could have change in temperature as well. Like for example, when we undergo a process of digestion, energy is released. We gain energy from the process of digestion. Okay, similarly there might be certain evolution of gas, certain formation of bubbles. Okay, there might be some evolution of smell. There are all of these observable changes that we can observe during a chemical reaction. Once again, what are observable changes? Observable changes are the changes that we observe in a reaction by which we would say that yes, this is a change, this is a process. Okay, most of them we are observing it in day-to-day life. Like once again I said, evolution of bubbles. The best example is when we use or when we open a soda bottle can, you observe evolution of bubbles, right? Okay, or another example that we can give is when you squeeze lemon onto baking soda, you observe formation of bubbles. Okay, then there is evolution of smell. Okay, let's say same, if we take example of ripening of mango, the mango on ripening, it changes its smell. After fermentation of grapes, the smell changes. Okay, all of these are example of nothing but a chemical change. Now when we talk about chemical reactions, a very important part associated with this is to write a chemical reaction. Like for example, let's say if I come across carbon plus oxygen gives carbon dioxide. Okay, let's say this is a reaction that we are talking about. Now understand, see, in this reaction there were only two reagents or only two reactants and only one product. So writing this reaction was very simple. But don't you feel that this would have been much more simpler if we could write in this form, that is C plus O2 gives CO2. Okay, it would have been a lot more simpler. It would have saved us valuable time. And therefore what we need to understand is, we need to understand that when we write a chemical reaction or when we are interpreting a chemical change, we have to follow certain rules which are associated with a chemical process, or certain rules which are involved in writing of a chemical equation. What are those rules? Let's try to understand. The first and foremost rule is you have to use proper symbols and formulas. Like for example, if I say that okay, today I don't feel like using C for carbon, let's say I would use A for carbon. That won't work. Okay, so you have to use proper symbols, you have to use proper formulas of the compound. Okay, you can't just wake up one day and say that okay, from now onwards I am going to call water as H2O2. You can't do that. Okay, you have to have the formula as H2O, and this would remain a universal truth. No matter wherever you are in this universe, water will have a formula of H2O and you can't change it. Right, so it becomes very important for me to understand that I have to write proper symbols and proper formulas. Okay, so let's take an example and we'll just mark those examples as we read the rules. Okay, so let's suppose I have an example, H2 plus O2 gives H2O. A pretty simple example. Okay, let's try to understand further. Now the second point says that the reactants needs to be on the left hand side and the products needs to be on the right hand side. So over here in this reaction, what we have written just now, we can say that all the things that are written on the left hand side of the arrow are the reactants. So these are the reactants, that is H2 and O2, and the products are always written on the right hand side of the arrow. Okay, so these are the products, that is H2O in this case is a product. You don't have multiple products, you have only one product. Okay, that's fine. Let's go ahead. Now the next point says that the physical states of the reactants and the products that are involved needs to be written in brackets. Okay, like for example, if I have any solid reacting, I would specify it with an S. For liquid, I would use L, G for gaseous, and AQ for aqueous. Now, sorry, what do you mean by aqueous? Let's understand. Okay, aqueous means nothing but simply dissolved in water. Like for example, let's say I have NaCl, normal salt. This normal salt right now is solid and I dissolve it into water, which is obviously liquid. This would be dissolved definitely, and upon dissolving you would have NaCl, which is aqueous. What do you mean by aqueous? Dissolved in water. Okay, let me add one more thing over here, although this would be very rare for you, but still let's add this because we are studying it up till this point. So let's go on one step further. That would be great for us. So what we can understand is we can also have things which are dissolved in alcohol, and then the solution would be referred as an alcoholic solution. As we have aqueous solutions, we also have alcoholic solutions, and alcoholic solutions are represented as AlC. Okay, so you can also remember this. Anyways, we have moved this far in recognition of all the states. Okay, so let's move further. So over here, let's try to write down our point. So H2, it would be in which state? So H2 is in its gaseous state, oxygen is again in its gaseous state, and water, it might be in liquid form, it might be in the gaseous form, depends upon the temperature. Right now I am putting it in form of liquid. Okay, so let's move further. Now the next point says that the condition for the reactions, if any conditions are specific, only then it needs to be mentioned on the arrow. So see, all the reactions won't happen just like that. Okay, you definitely need some things, some conditions for that reaction to occur. So whatever are the conditions related to temperature, related to pressure, related to catalyst, it might be anything. Okay, so whatever are the conditions that are required, those conditions needs to be written on the top of the arrow. Okay, so over here in this case, when you have H2 and O2, I would require a catalyst, that is platinum, and along with this I would require a small amount of heat for obviously starting the process. Now don't worry about what exactly is catalyst, we would learn shortly in this chapter. Don't bother about it. As of now, just go with the process. Okay, so catalyst is something that is required in this reaction to start the process. As of now, it's great. Okay, let's move ahead. So now we have already discussed about the conditions that are required for the reactions to be written on the arrow. Let's move further. Now over here, my dear students, understand the arrows can be of two different types. Okay, so the first type of arrow, it can be a normal arrow wherein it has only one head, whereas it could be a half-headed arrow which is pointing in both the directions. So whenever you have a normal arrow, this arrow symbolizes that the reaction is irreversible and it would go only from reactants towards product. Whereas if we have a half-headed dual arrow, this shows that the reaction is a reversible reaction. That means reactants can be converted to products. Similarly, products can also be converted back to the reactants. Okay, now currently the reaction that we have is an irreversible process, so that's the reason we have written it with a single headed arrow pointing from the reactants towards the product. Okay, let's go further. Now, the next point says that if in your products, understand this is only for products. Okay, so this is only for products. So, if you have in products, either you have the gaseous products or you have a solid product. Whenever you have solid products, they are represented by a downward pointing arrow, and the gaseous products are represented by an upward pointing arrow. Okay, so if you have, let's say, H2O for this example, let's suppose if it was gaseous, I would have drawn it with an upward pointing arrow, symbolizing that it is gaseous in nature. Right now it is liquid, so we don't need to put any arrow over here. Okay, so let's move further. Okay, now the next part and the most important part over here, okay, is that any reaction that you have needs to be balanced. Okay, and why does it needs to be balanced? Because you have to obey something called as law of conservation of mass, which says that mass cannot be created nor be destroyed in a chemical reaction. In a chemical reaction, you can't destroy mass, you can't create mass during a chemical reaction. Okay, so now over here, let's understand in this example, you have how many hydrogens on the left hand side? So over here, you have two hydrogens. Right now, on the right hand side also, you have two hydrogens. So hydrogens are balanced on both the sides. Let's now come to oxygen. So over here, oxygen, how many oxygens do you have? You have two oxygens on the left hand side, but then only one oxygen on the right hand side, and this is not balanced. So what we need to do is we need to multiply the products. Let me just change the color for you. So we need to multiply the products with 2. But now there is a problem. If we multiply the products with 2, hydrogen becomes 4 in number. So that's the reason we need to put 2 over here again, just so that the reaction becomes balanced. And finally, we have a balanced equation, that is nothing but 2H2 plus O2 gives 2H2O. And this reaction now, my dear students, is complete in all its respect. Okay, so what are the points when we need to remember when writing a chemical reaction? The points are, firstly, you need to use proper symbols and formulas. Reactants are on the left hand side, products are on the right hand side. That's fine. The physical states of the reactants and products needs to be mentioned. Okay, next, any reaction conditions needs to be written on the arrow. Next point is, if you have an arrow which is pointing in a single direction, that means the reaction is irreversible. If it is an half-headed arrow pointing in both the direction, it is reversible. Solids are to be shown with a downward arrow. Gaseous are to be shown with an upward pointing arrow. And finally, the reaction will be balanced to obey the law of conservation of mass, which says that mass cannot be created nor be destroyed. Now, I know that you don't know balancing as of now. You're not hands-on with balancing, but don't you worry, I'm there. Okay, so in the next part of this module, we will be trying to learn how exactly to balance chemical reactions. Okay, we would be talking about the rules which are required to balance a chemical reaction, and we will also be talking about few examples in that module. Till then, thank you students, enjoy learning.